So any question from last class? Um, if you want, we can do that. But if you see that in the module, I created a new module of solutions, and I will post the solution of assignment and the quizzes there. If you see there, I created a module. It says solutions for quizzes and assignments. I will post the uh, solved quizzes and the solution of assignment there. But if you want to go through, we can do that also. Yeah, no problem. We can do here also. It's not a problem. Okay. So let's see. We started last time this new chapter, which is about the transition graph, and I explained you that transition graph is more relaxed form of finite automata. TG, we call this as TG. So TG is basically used to represent, to define the regular language. So now you see this is the third method. First, you see that we define the regular language by regular expression, and then you see that we define the regular language by FA, and then you saw that today we will see that regular language can also be defined and represented by transition graph TG. So TG we saw last time that uh, is quite relaxed. You can pass instead of letter word toward the edges. It does not take care of garbage collection and lot other things. And TG can crash also. Why it can crash? Because I explained that your word can may be rejected and the rejection may be due to fail or crash. So TG can fail also, TG can crash also. Okay. So that's the thing. So uh, now look at this one. On an FA, it is not possible for any input to crash. Why? Because we take care of garbage collection. Every state 100% make sure that the outgoing edge will take care of all A's and B's. Every state should have unique, distinct outgoing edges of summation, which is A or B, because there is always an outgoing edge A and outgoing edge B from each state. As long as there remain letters, unread progress is possible. Whereas this is not the case with TG. Okay? TG does not have this case. So now if you see this, so now question is this a valid FA or not? So is this a valid FA or not? Jacob Sorensen, is this a valid FA or not? Oh, we cannot hear you. Are you writing or talk speaking? So Jacob, we cannot hear you. Okay. Nikhil, is this valid? It is, yes, it is valid.
It's
Uh,
valid.
so Nikhil, who is speaking?
Nikhil.
So Nikhil, is this a valid FA? Is this which is at this time which I show on the screen?
I think so.
Okay. So Nikhil. So can you please speak loudly those checks which we normally run in our mind to figure out whether it is valid FA or not?
So it would need one starting and like one
Exactly.
finishing state.
So one by one, it has exactly one start state. Perfect.
Yeah.
And it has final state, we don't care. It has may not, may, or maybe more than one, so that's okay. Now next.
It has it covers the inputs like both A and B.
Okay, let's see. First state taking care of A and B. Second state taking care of A and B. Okay.
Um,
I mean, not input, output. It's outgoing edges actually.
okay.
Okay. What is next?
I'm not sure.
It should have distinct outgoing edges. But if you see here, what is this? So,
Oh, I see.
so now, is this letter or is this word?
That's a word.
So this is not the case with FA. FA will never have a word as a label on the edges. Beside, if this state is taking care of A and B, so it should not have this edge. This is extra edge because we assume that summation is equal to A comma B. So one state maximum should have two outgoing edges, which is one for A, one for B, and this is a case here. This is extra edge, so it means that it is not taking care of it is that distinct edges and letter by letter toward the edges. So this is not a valid FA. Okay, so this is not a valid FA. So let me see. Uh, Jacob Sorensen. So this is not a valid FA. Okay. Uh, Now we can see that is this a valid TG? TG is okay, no problem. It has a start state and it can has letter by letter, no garbage collection. So TG does not care what's going on. Okay. So now if you have a word BAA and um, now if I so a choice of recipient to so now okay, so let's see that if I just pass one word uh, which is B and A. So B is one input and A is another input. So now I have a question with Nabhan Aziz. So is this word will be accepted or is this word will be rejected? Nabhan,
Are we talking about BAA?
yes, if I pass this input first B and then AA,
Should be accepted.
should be accepted. If I pass a word B and then uh, let's say B and A,
It would just stay in the initial state.
so what does it mean? It is accepted or rejected?
Accepted.
Accepted. If BAA is accepted, BA is also accepted. Both words are accepted. Either one is right or one is wrong.
Or is it just taking the, or is the BA one word, or is it two separate letters?
Just I'm saying B as a separate input and A as separate input.
It should be accepted. It would just stay in the initial state.
But that is my no. This is one complete word. This is second word. I'm saying this is second scenario. That's
Okay.
it. This word is finished here. B A is the last letter of this word.
So then it wouldn't be accepted.
Why? So what is the condition that word should be accepted? How you know that the word is accepted?
Uh, Not entirely sure.
Okay, no problem. James, no, Jacob Morris.
Yes.
So we have this word B as one input and A as this word, second one. Is this accepted or not? in this DG?
No.
Why?
Uh, ends in the initial state.
Yes. So Nikhil, not Nikhil, Naban, it is not accepted because the condition to be to for the acceptance is the last letter when you pass through the machine, you should finish at the final state, plus sign. When you pass B and AA, you have B here and AA here. This take you to here, and this word will be accepted. When you pass this B, and so this is first B and then A, it will again A here. So it is one round and the second round, and that's it. And you are finished at the start state. You do not reach to the final state. So this word will be rejected. So Nabhan, are you clear now why it is rejected?
Yeah, I understand.
That's great. So now my question with you is, Nabhan, it is rejected, I understand, but you know that rejected. A rejection has two criteria. One is fail and one is crash. Is this crash or is this fail?
Would be fail.
Would be fail. Why it is fail?
Because it just simply staying at the initial state and not going to the final state while crash.
No, 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 no. This is not the reason. Reason is this: you completely traverse whole word. There is nothing left in the word. You first have the pass B and machine is handling B. Then you pass A, machine is handling A. Your word finish, but you do not finish at the final state. You are at the start state. That's why it is rejected and it is fail. Now I give you another example of crash. Let's say you pass a word BAA as one input. Okay, so BAA as one input. Now let's say you are at the start state. Do you any state, any outgoing edge handle this?
Cannot.
Cannot, because we machine does not have any label which is directly handling BAA. So in this case, you pass a word, but machine does not handle that. Okay, so this word will be rejected. Or let's say if this and but this will be crash. Let's say I give you another word, which is B, and then uh, AA, not AA. I'm sorry. Uh, BA. Okay, BAA. Okay, and I pass B separate input, A separate input, and A separate input. So three inputs, three letters. So now in this case, what happened?
It would fail.
It would, how it would fail?
It,
Uh, yes, 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 it will fail. You are right. Okay, I I give wrong example. So this is you're right. This is fail. Perfect. Excellent. So now let's say if I say B and A and AB, AB as one input. Now what happened?
it would crash.
It would crash. Now you understand the difference between fail and crash, because you see we pass B, we have this loop here. We pass A, we have this loop here. And now we have AB. And we have a word or letter to pass to this machine. It is not finished yet, but machine is not able to handle to take that input and entertain us. Yes. So now it is again rejection, but this is crash. So this is crash here. But when you completely traverse the whole word, like this thing, so it will be rejected, but it will be fail. So that's a difference between fail and crash. Make sense?
Okay, makes
Okay. So
sense.
any question, if you have confusion about acceptance, fail, and crash?
So all good.
Oh, so good. That's great. Thank you very much. So
Mhm.
now this is good. So now if you see this, so this is best slide. It will explain you the acception and rejected and fail and crash. Okay. So all discussion is written here. So for all W member of file, if there exists a path that arrives at a final. Okay, so this is what I just explained to you. So now, anyone, if you have any confusion about fail, crash, and accepted, please let me know. Otherwise, we are good for this. Now, this is another machine. This is your another FA, and it has two possible paths to reach to the final state. One is if you give one input B A and then A B, then you reach to the final state. Look at this one. Or if you give one input B A as one word as input and then B and then you reach to the final state. So if I ask you, can you please write the regular expression of this machine? So the regular expression is BAB, sorry, B BAAB. Yeah, that's it. So it is BAAB. This machine is accepting a BAAB. This is the regular expression of this machine. Okay. So now let's see the formal definition of transition graph. Okay. So transition graph is the collection of three things. Now a finite set of states, at least one of which is designated as the start state. Now this is the difference. When you talk about FA, it says exactly one of which is designated as the start state. In TG, it says at least one of which is designated as the start state. So FA will have only one start state. TG may have one or more than one start states. Okay, so TG may have more than one start states. It has no problem. TG will be a valid TG if it has more than one start states. This is a difference from FA and TG. Okay, and some may be none of which are designated as the final states. This is the same criteria what FA has. FA also says maybe you have no final state, maybe you have one final state, maybe you have more than one final state. It is the same thing. An alphabet summation of input letters from which input strings are formed. This is again the same thing. So you will have the input will be from summation, which is A comma B. Okay. A finite set of transitions that show how to go from some states to some others based on reading specified substrings of input letter. This is not the case there in FA. FA will take care letter by letter. Here you can pass letter by letter or you can pass substrings also to that letter, possibly even the null string. A successful path is a series of edges beginning at some start state and ending at a final state. It is exactly the same. When you finish at the final state, your word will be accepted by the TG. If you do not finish at the final state, your word will not be accepted by the TG. The concatenation uh, of all the substrings that label the design, the edges in the path is a word accepted by this machine. The set of words accepted is the language of the transition graph. Okay, so that's the language of the transition graph. So this is basically the formal definition of TG. So what is the difference? TG may have more than one start states. This is a difference. FA does not have that, and TG pass the substrings of input letters. Okay, so FA just pass letter by letter toward the edges. TG can pass more than one letter. Okay, so this is the difference between FA and the TG. Now, this is another machine. Uh, my question is this a valid FA or not? And who will answer this question? Quinton, is this a valid FA or not? This machine, is this a valid FA or not? Quinton, I'm asking FA, not TG. This this machine. Oops, and what happened when I touch this machine? Is this a valid FA or not? No, it is not a valid FA because I mean it has multiple things on the same transition. But this is one thing. Beside, whenever you see it is passing more than one letter on any edge, you do not need to perform any other check in your mind. If you see this kind of thing, it means this is invalid FA. It is not an FA because FA will never pass a word towards the edges. It will always pass letter by letter. Okay, so this is not a valid FA. So now, is this a valid TG? Yes, it is a valid TG. It has a start state, and then we don't care. Okay, so now, if we, what is the word we can pass through this machine? So now if we have a word, this machine, this word A, B, B, A, B, okay? And I have this word and I ask you, can you please check that this machine, this word belongs to this machine or not? And you are confused at how you make a factor of this. So you think that I make a factor this way, first divide this into this part, so you pass A, B, B, and then lambda will take you without anything here, and then you have A, 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 A. So if you have, so then you divide this into A, and then you have B, and you are not able to handle B. So this word will crash the machine. This word will crash the machine. Because you are here, and still B is left, and we are not handling B, so this will crash the machine. But let's say if you have a word A, B, B, A, B. Now you are saying I make a factor. So it requires you to decide how to make a factor. Okay. So you are saying I make a factor this way. So A, B, B, and then lambda without any input, you go reach here, and then A, you go here, and then B, you reach here. Everything is done, and you reach to the final state. Whole word is finished. This way, this word will be accepted. So that's the idea behind that how the word will be accepted. Okay. So this is good. Now let's see this. So it says that, as I already explained you, the difference between FA and TG, that FA may have more than one start state. Look at this one. Now my question with you is, who will give me the answer? Let's see who is here. Riley, is this a valid TG or not? I put a tick mark here. Is this a valid TG or not?
It looks valid to me.
It looks valid. Perfect. It has more than one start state or one or more than one start state. This is one check. And then honestly, after that, we do not need to run any check. This is the only check we need to see. And it is just passing letters and the words and the final state is connecting. So this is a valid TG. It is not valid FA because FA will not never have more than one start state. So when you have this kind of thing, when you have more than one start state, we do not like that because this way machine will confuse from which state it should start. Okay, so this is kind of non-deterministic approach when you have when machine does not make decision by itself. So this is called non-deterministic. Okay, so now you read this slide. I'm coming just in 1 second. Huh? You read this slide. Just a minute. Okay. So now if you see this, this is a valid TG, but this is non-deterministic. We do not like non-determinism because this way a machine will not make decision by itself. So you need to make a decision. It requires human input to make a decision. So we do not like that. We want machine should be autonomous. It should make decision by itself. So now whenever have these kind of machines, you can reduce that to one start state, and that is very easy. You just add a new state here and connect all these states with this one, and and delete their start sign, and the label will be lambda, because you know lambda means without any input you reach from here to here. And this way you see we have multiple start states like this. We reduce that to one start state and we add lambda here, and it does not change the any behavior of the machine. Still machine have the same behavior. Okay, so these two machines are equivalent to each other. So this way we can reduce the multiple start states of the machine um to one start state. Okay, so these two machines are clearly equivalent. Every FA is okay. Now I have a question with you. Uh, let's say we go to this thing. Let me draw. Let me add a screen here. I want to. I keep it. Oh, what I did. Yes, yes. FA has FA can pass lambda, no problem. Uh, you know that who is asking question? FA. Quinton, yes, you know, Quinton, we saw last time when your start state is a final state, so that will be a lambda in FA. So that is the case. So FA can handle the lambda, no problem. That's the only thing. Actually, you raise a very nice question. So that's the only thing which FA can deal with, and that is not a word. That is not a letter. That is a word. So FA can handle lambda, but this is the only word FA can handle. Otherwise, FA never handle any word. FA just handle the letters A or B. So FA only handle this thing, and we saw that in FA chapter that if your start state is a final state, so you can handle lambda there, or you can pass. I mean. Explicitly the lambda sign also. Now I draw one machine in front of you. This machine is, let's say, start state, and all words start from A and reach to the final state, and then we don't care what is going on, A and B, and B is your, if the word start with B, it should go to the garbage, and then and that's it. So now, is this a valid FA or not? So the regular expression of this machine is A into A plus B whole star. It will accept all those words which start from A, and that's it. So is this a valid FA or not? Anyone? Okay. Riley says yes. How many? Okay, wait, there is one guy. James Evans. What do you think? Riley says yes. He says this is a valid FA which I just draw. Do you agree?
Yes.
You agree because Riley is your best friend, or is this your personal decision?
No, I think it's correct.
Okay, but Riley now changed his decision. He said no.
I still think it's correct, but I'm intrigued to see why he changed his opinion.
Okay, so if you see that this last state is not handling A comma B, so it is
Oh,
so
okay.
it was invalid. Now this is valid. I make it now valid. Okay, so now this is valid. Okay, now so this is good, very nice. So Riley, I am very happy that you guys are listening and you guys make participate in that. So now this is very nice. This is your valid FA. Now my question is, can I say that this is a valid TG also? Any one of you? Can I say that this is a valid TG also or not?
I think so, yeah.
James said yes. So Riley, what do you think? Okay, so you agree with James this time. So this is because you confused last time that you did mistake and James' answer was right, or this is your own decision? Own decision, good. Let's talk with who will answer this question? Anyone? Okay. Nikhil. Nikhil, do you think that this is a valid TG?
I believe so. The drawn one, right?
Yes, which I draw. Is this a valid TG? I'm not talking about FA. TG now. TG.
Um,
Before we
think so.
discussed, I discussed with James and Riley that this is valid FA. Before it was not valid. I make it valid. And now we are talking, is this a TG also or not?
I think it's also a TG because every FA is a TG.
Perfect. So every FA is a valid TG. Every FA is a valid TG. Every TG is not a valid FA. Okay. So Riley, you are 100% right. Perfect. So every FA is a valid TG because if you see that if this is an FA, what TG says? TG says minimum one start state, yes, and then TG does not have any restriction. Final state may not be there or maybe more. Same FA. TG says you can pass letter by letter. It's okay. I'm relaxed. You can pass word also on the edges. So that's okay. Garbage collection. TG says, I don't care if you do the garbage collection, but okay, if you are doing, I have no problem with that. But I do not care if you want to do or you don't do. FA says, no, we want to do that. So okay, you can do that. So TG has no problem with that. TG is quite relaxed. So every FA is a TG. Every TG is not an FA because when you do not do take care of garbage collection, when you pass word, so this will not be an FA. But if you draw a TG and this TG is exactly meets all the conditions of FA, so then yes, that will be FA also. So every FA is TG, every TG is not FA. Perfect. Very nice. So now we are saying that we did this. So this is every FA is a transition graph, but not every TG satisfies the definition of an FA. So this is very good. So now we are saying that, look at this one. We have this machine here. So this is your TG that accepts nothing. It a start state. It has no final. You know that when there is no final state, so the word will not be accepted. So it is doing nothing. It is just a file language, and it is a TG. Okay. So now my question is, if I want to convert this TG into FA, what I need to do? How I convert this TG into FA? I have this TG here, which I just circle, and this is valid TG. I need to convert this into FA. How I convert this into FA? Gunnar, can you help us? How we convert this into an FA? So you need, Gunnar is saying something. So you need transitions for A and B and a final state. And a final state. So I don't know how if you guys can draw on the screen. No, you cannot. So but how we do that? No, Kunar, I don't think so that your this whole statement is right. You're partially you are right. Final state is not a requirement. Yes, you do not need a final state. It is optional for FA. Yes, you are right, Riley. Quinton. It is not. It is that is the mistake here. So now, if I want to convert this, I will do something like this. Start state, and then I will say A comma B, and this goes to another state, and then here A comma B, and this is the uh, valid FA for this, because if you see this, you are taking care of A and B from this state, A and B from this state, and there is no final state. It is not doing anything. It is a file language. Okay, so this is a final. This is the file language of this machine. So Gunnar, do you understand now? We don't need the final state, because if you have a final state, so this is not good. We are creating a language which is file language.
Yeah, I understand.
That's great. So now we are saying that we have this machine here. So now this machine is taking care of lambda, because your start state and it is accepted at the same state without any input. So it is accepting lambda. Okay, it is not accepting any A or B. So now if I want to convert this into FA, so I will do this, and then I will create A comma B, A like this, and then A comma B, and now this is valid FA equivalent to this. This is valid FA. See, so how TG is very simple. TG does not, what is this basically? This is your garbage collection. So TG says don't need to do the garbage collection. What is important, just do that. So we are doing that. So now we have this machine here. So it is a start state. It is two start states, lambda and BAA, and UD here, and then start states here. So this is at valid TG. It is no problem, because it has more than one start state. It's okay. TG says you may have more than one start state. So this is valid TG. It has no problem with that. And then you can have so what is the regular expression of this TG? It accepts one word A, B, B, A, and then it accepts another word which is B, A, and then it accepts lambda. So this is the B, A plus yeah, this is the regular expression of this machine. Okay, well, look at this one. So it is written here. TG, in which some start state is also a final state, will always accept null string. So this is basically, it is accepting a null string there. Okay, so you may have lambda by this way, by this way, by this way, by this way, and this way. So all these are different examples of lambda. Okay, so you can have lambda. This is also lambda. So you can have a loop of lambda, doesn't matter. You can start and the final plus sign with lambda, or start lambda. I mean, it does not matter here. So it does not have any start state. So this is lambda, because it does not have any start state. So if you do not have any start state, because minimum at least one state should be start state. If it is not, so it is not doing anything. So this is not lambda, sorry, this is phi. It is not doing anything. So it is an invalid machine. It is not valid TG. So this is not valid. Even if not phi, it is not valid machine, because it is not doing anything, and it does not meet the basic requirement of TG. It does not have a start state. So this is not a valid TG. Okay, so this is something which we just see today. And now let's see this. I have this FA, and it is written there FA, so it means this is valid. And let's see what is the language this FA is doing. So first let's revise this. Valid, this is valid FA, or whether this is valid FA or not. So now we will say that it has one start state, strictly perfect. Final state not required, but it is there, good. Uh, every state should handle each A and B outgoing edge. So it is handling A and B, very good. This state is handling A and B, very good. So perfect. So, and all letters are, all labels are letter by letter. So this is good. This is valid FA. Now, what this FA is doing? This FA says you can start a word with A, you can start a word with B. And you have a loop here. As many A's, as many B's. And then A, and then B, and then A. As many, so all these are the loops. Okay. But whenever you want to finish and the word should be valid, it will always end with B. Whenever you have A, you are at the start state. Whenever you have B, you are at the final state. So this means that at least last letter should be 1B, minimum 1B. You will have more, no problem. Minimum 1B, and then this word will be accepted. So now if I write the regular expression of this, A plus B whole star B, because it gives you guarantee that the last letter should be 1B. You can get more B's from here, but 1B must be there. Okay, so this is the regular expression of this. So now I want to convert this into an F into TG. So I'm saying that, okay, let's try to convert this into TG. So we have this start state, and initially A or B as much, and to reach to the final state it should be B, and that's it. So look at this one, how easy it is to draw the TG of your FA. Okay, so I mean, this is, you reduce the number of edges, but if you if this is an FA, you can, if I ask you draw the TG of that, and I do not put any restriction, if you redraw this is the same answer because this is TG also. Yes, so this is TG. Every FA is TG, so you can redraw this. But let's say if we want to simplify that, so and do not take care of garbage collection, so this is a simplified version of TG of that FA. Okay, so. So some words can fail, some words can crash and succeed. So this is basically the idea behind that. So far, any question, guys?
I have a question about the transition graph one.
Yes, please.
So it looks like there are two transitions for B, right? So how do you know which one to use?
Which one? Are you talking about the second diagram?
Yeah, the second diagram.
Yes. You are right. Perfect. So that what does it mean? If this is a case, so Gunnar is very excellent. You have very good eye. So look at this one. So now if you have a word start with B, and how you know that you should follow this B or this B? Yes, this is your question.
Yeah.
So this means that TG is non-deterministic. This means this. TG, in this TG, it requires you to make a decision which path you should choose. TG is non-deterministic in nature. This is not the case with FA. If FA does not require user wisdom, human wisdom to make a decision. FA is an autonomous machine, and this is deterministic. TD is non-deterministic. So we don't like non-determinism. But thing is, if machine is non-deterministic, so machine will become very powerful and less computational cost, less resources. So we apply some rules and restrictions on the machine, and the machine which is non-deterministic in nature, by those rules and restrictions, it will behave in a deterministic way. We will see in the coming chapters how we make a non-deterministic machine into how a non-deterministic machine behave in a deterministic way by applying additional rules and restrictions. Okay. Is this answer your question?
Yeah.
That's great. Yeah, so you are perfect. It is right. This is non-deterministic. TG requires user input that how to do that, because it can have the same more than one outgoing edges. So this is not a valid FA. This is just TG. Okay. So I don't know. This is just TG. It's not valid FA. So now let's go to the next slide. So I have a question that this diagram, is this a valid FA or not? Quentin asks some question. Does that say that the word AB crashes? How does it crash? Where? Quentin, which slide you are talking? So guys, you can ask a question, you can speak, sometimes I don't read your chat, so I miss 13. Oh, here, AB, can fail. Yeah. So let's see. Some words can fail, crash, succeed. So yeah, because if you have A, B, so now it depends that how you choose this machine. So now if you choose A, B, this will be fail. It finish at the start state. If you choose A, B, A, B, it will be pass. It will be pass here. Yes, it will be accepted because the last letter will reach to the last to the final state. And now look at this one. You choose A and then B, A and then B, and still you have A and B here. So now machine will crash. So this will machine will crash in this way. So this is the idea behind that. So it requires you to choose that how you should move from one state to another state. And in this case, this is not the case with fa will never crash. Fa is deterministic. There is only one way to reach to the final state, and fa will always be follow that path, whereas tg is non-deterministic. Now, is this a valid fa or not? Quentin says no. Why? And people are agree with him. So Riley agree with Quentin. So Quentin, why it is not a valid FA? Let's talk with Nikhil. Let's say that no, so not sorry, Nikhil. This one, Nabhan. So Nabhan, what do you think about this? Uh, why this is this a valid FA or not? Nabhan Aziz, is this a valid FA or not?
Not a valid FA.
You said no.
No.
Why?
I'm not entirely sure.
No, but when you say no, so there must be something in your mind that makes you convinced that you should say no. Otherwise, you will say yes. So, what is in your mind that force you to say no?
Because when you get like A, B, then it'll just be you have to choose which B is going to for the transition.
You know, your answer is right. Your answer is what you are picking. I believe it makes sense, but a little bit more elaboration of that. So, which state you are talking here now?
When it goes to from A,
This one.
there's the A, B, and B.
This one you are talking, yes?
Yeah. So if I have like B,
and you see that one B is here and one B is here. This is you are saying? So now this is you pick very right answer. This is one of the reason FA will never have duplicate outgoing edges. You see, one out. This is outgoing, huh? But it comes. It's a self loop, but it is outgoing. What comes to itself, but that is outgoing. So this is outgoing edge B, and this is outgoing edge. It is not the case with FA. FA will never duplicate. It has distinct outgoing edges. So Nibhan, Damhan, it is perfect your answer. There is one more mistake here. What is that?
the same.
The same thing is here. Yeah, I mean, I consider this as a same thing. But there is one more mistake. Other than this kind of mistake. So did you find another mistake?
Oh, Dr. Abid, your microphone is messing up again.
Oh, what do you mean messing up?
Doing what it was doing before, being really, really loud and really hard to hear you.
Let me close this. How I did this last time. And go ahead and do a video connection. Disconnect. So is this good now?
Yes.
Okay, so now we know how to fix it. This is good. So now we are talking, Nabhan was telling us that what is the other mistake. So perfectly he figured out two mistakes, 100% right. You are right, Nabhan. There is one more mistake and a different kind of mistake, not this kind. Are you talking or I'm not listening to you?
Sorry. Are you talking about the A's for the bottom one?
Which one?
For the letter A's?
Something at this stage. Okay, let me mention you. Something here and here.
Is it that there's no transition if it takes any input after that?
Yes. So what happen if you are here and you receive another A and B? Yes. So you are not handling that. And what happen if you are here and you do not receive A and B? So you are not handling A and B here. So it means that this is another mistake which we have here. So this is very good, very nice. Let's see that if someone says any question. Okay. So now this is good. So this is a valid, but this is a valid TG. TG, it has no problem with TG. TG has no issue with that. So accepts language of all words that begin and end with different letters. So start with A and uh, start with A and end with B, start with B and end with A. So this is basically a valid TG, but not a valid FA. So now we have this another machine which is valid TG but not valid FA because you see this that it has two A's here and two A's here and look at this one B, second B. So too many B's are outgoing edges. So this is all these mistakes which make this machine invalid FA. And we are not taking care of garbage collection here. So this is also a problem. But this is a valid TG. TG does not have any issue with this. TG says, oh, this is fine. And what this machine is doing, it is accepting the language of all words in which the A's occur only in even clumps. So whenever you have A, it will be even in multiple of 2 and the word end in 3 or more b's. So to reach to the final state you need this one b, this may or may not, this must be there, this must be there. So minimum 3 b's to reach to the final state. So is required in this machine. So that's basically the language of this machine. Okay. So now let's go to the next slide. So we have this machine which is called even even. You already saw this in FA. So in the FA chapter, so it is even even. And now if you convert this even even into TG, so look at if I say reduce the number of states, how I ask you this question, I will say we have this FA, it is using 4 states. Can you please reduce this into convert this into TG, but reduce the number of states? May let's say 2 states or 3 states, something like that. I will mention there in the exam. So then we are saying that okay. So now look at this one. We have this. It is equivalent to this one. So now this is again your FA, but it is. Oh, this is again your TG, but it is TG of the even language. even language. So now it is doing the same job. It accepts the same language but reduced number of states. And if you see that it is the same thing. So two A's and then uh, one A and one B and then two A's, and this one A and one B make it two A or two B. So either this combination or this combination or anything cross, but this one will make combination of this one make it always two. So once you reach to the final state, so you have even number of A's and even number of B's. So that's the idea behind that. Good. What is the question? Could that TG handle 3A's, 2B, 3A's? Let's see how we, because 3A's. So if we have 3A and B, A, and A. So how it will handle? So first of all, 3, 4, I think it should handle. It should handle. Because if you see that two A's will be here, and then we pass this AB, it will be here, and then oh, then it has then it is not handling B. Oh no, it handle BA. It handle BA. It handle BA. This one, and then last two A again here. So yeah, it handle. You see, it should work. Gunnar, did you see that? So we can pass this word like this. So A B A is good. So yes, it can handle this thing. Gunnar, is this answer your question?
Yeah.
Okay, that's good. So yeah, this is good. It can handle that. So now let's go to this machine. Look at this now. The pain, you will feel the pain here. I have this word, and I want to see that this is not a FA for sure, because BB, and this one. So this is not an FA because of this and a lot of other things. Is this machine accept this word or not? This is my question. So now you see that we are not talking about 100 states or 200 states. We have just 1, 2, 3, 4, 5, 6 states. But because machine is non-deterministic, you need to make a factor different ways by your own choice. So which will suit and which will take you to the final state. And somehow it looks beyond impossible with the human eye that we can do this. So we require an algorithm, we require a method which will tell us that this word is a valid word or this is invalid word. And beside, we do not like this non-deterministic approach. Because of this non-deterministic approach, this makes this machine very hard. If this is an FA, we have certainly no issue with that, regardless how big that machine is, because we know we always pass letter by letter by letter by letter. But this is FA, no, this is not FA, this is TG. So we have no idea that how we break this. Should we go A and B, or should we go by three B's because it has three B's here? How we go that? So we need to see that what factor suits you and that leads you to the final state. We make a factor accordingly, and then we will say that whether this word will be accepted or rejected. If rejected, it is fail or crash. But it looks quite impossible with the human naked eye that we can do that. So we need a method and algorithm to do that, and we will see that in the coming chapters we will find an algorithm and we will convert our non-deterministic machine by applying additional rules and restrictions, and it will behave as deterministic, and that makes and help that will be helpful, and that will be able to find the solution of these complex machines. Okay, so that's the idea behind that. So this is good, but I just for the curiosity, I will tell you this word will be accepted by this FA, this TG. There is a way to make a vector, and that word will be accepted in this machine. So now we have this another machine here, infinitely many paths for an AA. So is there an algorithm to determine if a word is accepted? So yes, there is an algorithm. We can figure out that. So now it says there is many way to reach to the final state. You have just two ways, or no, it's not. It's not. It's with a greedy approach with large substring transit. So no, we will. No, it's not that thing. It's a different way. When we cover the ninth chapter, and then we will see after ninth chapter. We will make the production rules, and we will create some rules and restrictions. Uh, I don't want to say the name of that right now, but just for you, I'm saying if you understand, you will not understand because I didn't teach you yet. It will come in the future chapters. We will follow the leftmost derivation, and by that we make some rules uh, that will work actually. Okay, so no, it's not greedy approach. It's something else. So is there an algorithm for so how many ways you will pass a? So yes, a will go by this way, by two a's, or you can pass lambda a, or lambda a, or lambda a lambda a. So anyways you can pass a word, and this word will be accepted. You just need two a's there, and you can use this lambda because it is a loop, so you can use this as many time as you want. Okay, look at this one. So a, as many lambdas here, or this a, or a lambda, b lambda, as many times, but you require minimum 2a to reach to this one, so you can reach to the final state. So here we finish TG, and now we start generalized transition graph. This is it says it is called GTG. Generalized transition graph is the it is exactly the TG, but more formal definition, you can say. And this will give you actually the idea, the power of your TG, how TG is powerful. It says that a finite set of states, at least one of which is designated as the start state, and some maybe none of which are designated the final state. Exactly the same definition. An alphabet summation of input letter, exactly whatever TG says. A finite set of edges connecting some pairs of states, each labeled with the here. So now you know that if I say that TG can pass a regular expression. So now if I ask you, so if I draw one TG, let's say I have a start state. You need to tell me, is this valid TG or not? And it is passing one word B A, and then it is passing another word BA. Is this a valid TG or not? This is a valid TG because it is doing a good job. It is taking care of two words. If I ask you to write the regular expression of this TG, so it will be BAA plus BA. This is the regular expression of this TG because it is just accepting two words. Okay. So now if you, so everybody agree with me, yes? You guys agree with this? What I
Yes.
just mentioned? Very good. So now I have a question with you, that if I draw a FA, so and this FA will pass one word BAA. So start BAA. and then we take care of garbage collection. A goes here, and all A and B goes here. B comes here. B will come here. A comma B come here. So I convert the this machine will pass one word BAA. That's it. Yes, this is valid FA. I draw a valid FA, and you saw this in the FA chapter, that which is just passing one word BAA. Now, if I ask you, can you please write the regular expression of this machine? So what is this? It is this. This is a regular expression of this machine because it only accepts one word. That's it. It's not doing any other job. So this is the whole language of this machine, BAA. And now, if you see here, I pass BAA at one as a label of one edge, and another regular expression as a label of another edge. So can we say that? So now FA will take care of one language. Can we say that in TG, each edge will take care of one regular expression which is equal to one language, because regular expression define the language? And yes, we can say that. Look at this one. So if you have a TG, so from here to here, this, if this is a regular expression, it might represent one language. This is another self loop, it might represent another language. This is, all these are regular languages. So this is, can you see, this is the scope of your TG. FA will only represent one language. TG may represent one language at one edge, and then another language, another edge, another language, another edge, another language, another edge, another language, another edge. So TG may represent more than one regular languages by one diagram. Okay, so that's idea behind that. So TG is very powerful. It may represent more than one languages, and in one diagram, and each language will be represented by one edge, because one edge will be the label, and label can be word, and word can be, might be like BAA is the only language here, and look, I pass BAA just as a label here. That's it. So it is, you pass the whole language on the one label. So whereas FA on a whole represent just one language. So this is the power of your TG. TG is non-deterministic. It represents more. It may represents more than one languages. Okay, because it passed the regular expression towards the edges. Hopefully you understand this, and if you have questions, so you can ask. So let's see now this machine here. Words without two B's in a row. So you are saying that you will never have two B's in a row. So this is again your TG. So now, I mean, this is another, as much as TGs you can create here. So start and plus sign, all A's, and then BA and plus A star, and B plus lambda and A star. So this is your TG, which is take care of that. You will never have two B's there, two consecutive B's. Okay, so this is your TG here, without two B's in a row, not two consecutive B's. Different scenarios will come now. So clean star. So if you have a, so this is your another. This is not FA, because if you see, it is not FA because, no, it is FA. A and B, B and A and B minus. Yeah, this is valid FA. This is valid FA. It has no issue with that. And now you can convert this into TG. So you can have A or B, B star, A, and A plus B star. So this is, you apply the clean star on that actually. So it is clean star now. So how we, if you apply clean star, how it will look like. So this, it shows you this thing. So I mean, simply you are just applying a clean star and the loops. And then you are saying that choosing transitions. So you can have some time. So this thing ABB, ABB, or you can extend this. So you can, the same thing A, B, and B, you divide this into two parts and make it more simple, and this way. So it depends that sometimes you wanna input simple, and you, but if you have more states, it will cost you more resources, more computational cost, but I mean, you can reduce that into number of states. You can increase number of states as requirement. Okay, so you can do that. It's the same thing. So these both are the same thing. Working. Anyways, so this is the same thing. So now let's see this. So choose choices even with restrictions of one letter per edge. So if even if you have one letter per edge, you can extend the number of states. Look at this one. If you just add, if you delete this here and put lambda here and put a new state and put b here, so it is the same thing because you reach from here to here by b and you reach from here to here by just one input b because lambda does not require any input. If you are here, it is lambda. So you without any input, you reach here and then you need b, you reach here. So it is the same thing. So this is basically, so what we are trying to prove that TG is non-deterministic. So you can have another thing, look at this one. You can have more duplicate output edges B and B. So this is basically makes this machine non-deterministic. Now let's see this thing. The ultimate path through machine is not determined by the input alone. Therefore, we say this machine is non-deterministic. Human choices becomes a factor in selecting the path. Machine does not make all its own determinations. So machine is not. I mean, so and TG is non-deterministic. Okay, but every FA is TG. Every TG is not FA. Okay, so this is one of the major difference of this thing. So and TG also represent regular languages. FA also represent regular languages. Uh, regular expression also represent regular languages. Okay, so all three things represent regular languages. So here we done this thing.
One question. So, if every TG or yeah, sorry, if every FA is a TG,
Yes.
and every FA is deterministic, does that mean a TG can be either deterministic or non-deterministic?
Yes, you are right.
Okay.
But I mean, when we will, yes, I mean, yes, here in this way you are right. But most of the time, uh, you know, uh, uh, the use of TG is to reduce the computational cost of your FA. So if you, so it is, I give you example this way that something which you achieve by walk, you will not go by car. Yes, so if you just go to the next to the street or in your home, you can, if you want to go to the next room, you will never, don't use the car or cycle to do that. You can do that, it is possible, but it's not required. It is wastage of the resources. So now if you use where it is where it says that TG is required and you use TG with all the possibilities of FA, so then basically you are exploiting that facility what TG provides you to use that. So when we use TG, we most of the time we don't take care of the garbage collection and we use less number of resources and it is different from FA. But yes, technically what you are saying is right, because every FA is TG. So in this case, TG may be deterministic, TG may be non-deterministic. But on large, if I ask you this question, its answer is TG is non-deterministic.
Okay, thank you.
So I mean, if there is, if I in exam, if there is, or in quiz, if there is no option of TG is deterministic or non-deterministic, so you will only choose TG is non-deterministic. But yes, you are right. If we think the way you are saying, TG is non-deterministic and may be deterministic. But just if we, but I mean, normally we say that it is just not deterministic. So here, guys, we finish this chapter, and I think that if that is the case, so I should stop it here. I should not go to the next one because, okay, so next, uh, and this is, I try to thank you, all of you, with all possible, languages. And if you know some other language, so you can help me, and we can add that here also. So now we will start next chapter in next class, and that will be, I believe, chapter 7. And uh, I am thinking that might be our quiz is due because we finished chapter 6. And let me see that. Let me actually stop sharing my screen first and stop recording. How I stop recording? Here. So stop recording.